All right, y'all, we have finally reached the final unit in your AFM class. And this is on probability and statistics a little bit. We're going to talk about being able to find different possibilities of things happening. What's the possibility of you like drawing like a die out of this type of scenarios and different things like that. So today we're going to talk about what's called, this is our Unit 7 Day 1 notes. It's talking about fundamental counting principle. And the fundamental counting principle is used to find the possibilities of an event happening or events happening. And this is usually when you have like different options of things to do. Like, for example, when you're talking about how many different ways you can make a sandwich. Like if you use wheat bread or white bread, and then what kind of meat you use, and then what kind of cheese you use. So this is like going to help us with being able to find out the total amount. So for example, we have ice cream and we want to come up with either a cup or cone. And the flavors are available in chocolate, strawberry, and vanilla. So one way to find all the possibilities is create a tree diagram that shows all the possibilities. So like, for example, we've got a cup or a cone. So we're going to either have one or the other. You can't have both, okay? So you got a cup or a cone. And in that cup or cone, you're going to have one of 3 different flavors. So you can have a cup and you can have chocolate, strawberry, or vanilla. Or if you chose a cone, you could have also the same 3 options, chocolate, strawberry, or vanilla, which means we have 1, 2, 3, 4, 5, 6 possibilities of how you can have your ice cream. Now, this one was an easy tree diagram to create, but say, for example, you're trying to find out how many possibilities you have, like I said, with a sandwich. You have, like, say if you're at Subway and you have 6 different breads that you can choose from. You have like 5 different meats and then 4 different cheeses. That's going to be a more detailed tree diagram. So another way to do that is using our fundamental counting principle. And if one event can occur in M ways, so like 5 different types of bread, and another event can occur in N ways, like how many different meats, then the number of ways that event occurs is M times N. So like, for example, we had 2 different ways to either have a cup or cone. So you could have had a cup or a cone. So that's 2 ways. And then you also had your flavor, which was chocolate, strawberry, and vanilla. So that's 3 ways. So all you had to do there was multiply 2 times 3 to give you those 6 possibilities. So notice it gave me the same answer without having to do the tree diagram. Okay? So for another example, say we want the total number of possible outcomes if a die is rolled and then a coin is tossed. So when a die is rolled, remember that's 6 different sides. So that's 6 different options. So with the die, that means you have 6 possibilities. And if a coin is tossed, there's 2 options, either heads or tails. So that's 2. So that means the amount of possibilities that could happen is 6 times 2, which is 12. Okay, easy peasy. All right, and I'm going to flip over to the next page. The notes, I think, are only 1 page front and back. Yep. Okay, so another example. So we have a takeaway that is a 4-piece lunch special, which consists of a sandwich, soup, dessert, and drink for $25. That's kind of expensive, but whatever. They offer the following choices. For sandwich, you have chicken mayonnaise, cheese and tomato, tuna mayonnaise, and then ham or lettuce. So that's 1, 2, 3, 4 options for your sandwich. Okay? Then for your soup, you have tomato, chicken noodle, and vegetable. Okay? So we have 3 different soups we can choose from. Okay? Our dessert, we have ice cream and a piece of cake, so that's only 2 options there. And then with our drink, we have tea, coffee, Coke, Fanta, and Sprite. So that's 5 different drink options. So we want to know how many possible meals a person could have if they wanted to. If I wanted to make one of each meal that's possible, what would that be? So we could, of course, draw a tree diagram, but that would be a huge tree diagram, okay? Or we can just multiply these numbers out. We have 4 sandwiches times 3 soups times 2 desserts times 5 drinks. Okay, and when we do that in our calculator, 4 times 3 times 2 times 5 is 120 possibilities. So there's 120 different meal possibilities that you could create there. Okay, so that is how many possible meals you could create if you had gone there. All right, so let's look at the next example. Suppose you want to create a 6-digit password, okay, and your password may contain any letter in the alphabet and any number from 0 to 9, okay, but letters and numbers must alternate. How many password possibilities are there? Okay, so we want to alternate our letters and our numbers. So letter, number, letter, number, letter, number. And it doesn't matter whether, in this case, it doesn't matter whether you start with a number or a letter, because either way, 1, 2, 3, 4, 5, 6, I'm going to have 3 letters and 3 numbers. If, say, this was the beginning, I still would have 3 of each. Okay, so in order, we need to figure out how many options or possibilities we can create this 6-digit password. Okay, well, with your letters, you have all the letters in the alphabet, and in case you didn't know, there's 26 letters in the alphabet, so that's 26 3 times. And then from 0 to 9 is 10 different options, because you have to include 0. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 different options. Okay, if it was 1 to 9, then it would only be 9 options. But when you include 0, you have to include that as a possibility. Okay, so that's 26 times 10 times 26 times 10 times 26 times 10. Okay, just for my little smarty pantses there's another way you can write that. It's 26 to the 3rd power, because that's 26 3 times 10 to the 3rd power, because 10 happens 3 times. So either way, same answer. So 26 times 10 times 26 times 10 times 26 times 10. Or if I did 26 to the 3rd times 10 to the 3rd, either way is going to give me the same answer. Okay? And that gives me 1,757,6,000. So that's 17,576,000 options. So this is one of those reasons as to why, like, for example, in real world, you would want a longer password or a more variety of a password. Like whenever you're trying to create a password and they tell you to create a capital letter and a lowercase and then an exclamation point and a number, that's because the more different variations that you can have, the less likely someone can hack your account and guess what your password is. So that's why they always want you to create one capital, one lowercase, because then not only do you have, like, for example, say I did like Wildcats1 as a password. Wildcats, if you have a capital letter, I could have W as either an uppercase or lowercase. That's 2 different options that someone could get wrong. And eventually, most of the time, you get locked out if you don't have it. All right, so then our last example says, what if you must work within the criteria above, but now your answer is only 5-digit? Does it matter if you start with a number or a letter in terms of our password possibilities? So let's split up into 2 different options for our passwords. Okay, it's asking, does it matter if I start with a letter or a number? And this time we only have 5 digits, so let's look. Okay, so say we start with a letter, then a number. Ooh, what am I doing? Number, letter, number, letter. And then say I start with a number instead. Number, letter, number, letter, number. Okay? So then with our letters, you know there's 26 possibilities that you could have. And then with our numbers, we're still doing 0 to 9. So then that would be 10. And then you can always be given a problem like you're using all the letters except for a vowel. So you would take out A, E, I, O, U. So that would bring that down to 21 options, okay? And so that's a possibility of a problem that they can give you, or I could give you on your test, saying you can use all the letters of the alphabet except for vowels, or you can use all the numbers in 0 through 10 or 0 through 9 except for even numbers or odd numbers or whatever. So that's a possibility of a problem that could happen. Okay, so then we want to find out how many possibilities there are. Okay, so here, again, just rewriting it, that's the same thing as 26 to the 3rd times 10 squared, because 10 happens twice. So 26 to the 3rd times 10 squared which will give me 1757600. So 1,757,600 options. Okay, and here that would be 10 to the third times 26 squared. Okay, so 26 squared times 10 to the third gives me 676,000 options. So yes, if you look, if I had, the more letters I had, the more possibilities, because there's more letters than there are numbers. So if I have more options, then yeah, it's gonna make a difference whether I start with a letter or a number. So yes, more letters equals more possibilities. Okay, so that, to answer this question, it asked me, does it matter if you start with a letter or number? Yes, because you have more possibilities if you have more letters in your passcode. Right? So that's the fundamental theorem principle or whatever. Okay, your classwork is 2 pages, 1 page front and back if you count it like that. You're just going to answer all the questions that it asks you. Okay, make sure you answer all of them. In here, I think, it says if the digits can be repeated, ignore that part. We'll talk about repeating stuff on a different day. But it says how many passwords are there? And so, again, 4-digit password. Remember, if you're putting in individual digits, you can't put in 10 as an individual digit, or 11 or 12. So whenever it's talking about digits, it's still talking 0 through 9 there for your classroom. So you're going to answer and tell me all the options that are possible for each one, okay? Same thing here. You're going to answer how many possibilities there are for each problem, okay? If you have any questions, feel free to message me on Remind, or email me, or comment on the post on Google Classroom, okay? If you have any questions at all, let me know. All right. I missed you guys so much. I hope I get to see you guys at graduation or something. So hopefully this stuff gets itself figured out. But I miss you. So bye.